Hello and welcome back to Ganesh Institute. In today's video, we are going to solve least square problems by the normal equations. Least square problems means you have to solve x and y values in a matrix when it is given in a matrix form. So let's see how we can solve them. So when you have a pair of equation, let's say x plus y equal 3 and 3x plus 4y equals 2. So how you will solve it using matrix inversion method? You create a matrix A and B. A is having the coefficients of x and y, right? And B is having the coefficient of, these constant terms. And you apply this formula Ax is equal to B. You put the value of A here, x as the variables and b here, right? And you solve it. But this method is applicable. Yes, you can find out the values of x and y, that means variables here. But this method is available, or you can apply this if the set of this system is having the consistent solution, right? This system is consistent. What if the determinant of A is 0? How you will solve the set of system if the system is inconsistent, having no solution? Still you have to find out the solution if question will be asked. Then how you will solve it? So for that we have this least square problem which we can solve by using two types of method. One is normal equation and another one is QR decomposition. So we will discuss them one by one. In this video we are covering normal equation here. Okay, what this method says that, let's say if you have a set, if a system Ax is equal to B, okay, that means a set is given or matrices are given to you and you can create it in the form of Ax is equal to B, right? But you later on find out that this system, if we want to find out the values of x and y, these are not determined or we can't find them. Okay, so for that, okay, you may have this type of question that how we cannot find out the values. So let's say if x plus, there is the equation 0x 0y equals 0. So you can't have any type of value for x and y, right? So inconsistency is there. So for that you can apply normal equation method. In this you have ax is equal to b. The only thing is you need to find out using this least square problem, and for that you will multiply this set with the transpose of A, okay, to both of the sides. A transpose AX, A transpose B. Now, and please remember that this is only for inconsistent system, okay? So you need to find out the transpose, the value of A, X, AT and B, and from there you can find out the value of X. How? Let's take an example. So the question is, show that the system Ax is equal to B with A is equal to this and B is equal to a column matrix is inconsistent. So first part is to solve that this system Ax is equal to B is not having any solution. Okay, so for that you just need to simply put the values of A and B in this set and find out the value of X. If you are able to find out the value of X, then that means system is consistent, and if not, then system is inconsistent, right? So let's start. Ax is equal to B. A is 2, 0, 1, 0, 1, 2. X is, we have to find out, we have to place the values. B is 1, 0, 3, right? Now, you will see the order of A is what? There are 3 rows and 2 columns. That means 3 by 2. Right. So now the order of this X matrix should be started from 2, right? Because these 2 elements these two numbers need to be same. And because X is a column matrix, so we will be having only one column. So this order will be 2 by 1. So we can have two values of X in one column. Correct. Now find out the values of X1, X2. You can use any of the methods. So let's create augmented matrix here. Augmented matrix, what you do in it? You have value of A here and then value of B here, and we are using Gauss-Jordan method, right? So you have to create some echelon form sort of thing. So how we'll create it? If we do, let's say in R3, if we interchange R1 and R3, what will happen? We will have first pivot in the first row, right? And here we'll be having interchanged form, and then we are not touching second row, so it is simply here, right? Now we have 0 here, that is fine. We have to create 0 here as well, right? So what we can do, R3 tends to R3 minus 2R1, because 2 minus 2 will be 0, right? So here we are not touching R1 and R2, so just simply write them as it is. Now for third row, what we have, 2 minus 2 is 0, 0 minus 4, then we have 1 minus 6, right? R3 minus twice R1, 1 minus 6 is minus 5, right? So we have this form. Now we have another pivot here, so we have to create these two as zeros, right? So for R1, what we have, we can create 0 by take away 2R2, sorry, right? And then for R3, if we simply add 4R2 here, then minus 4 plus 4 will become 0, right? So let's see, we are not touching R2, so simply write it as it is. And then R1 minus 2R2, so 1 minus 0 is 1, then 2 minus 2 is 0, then 3 minus 0, 3, correct? Then we have in third row R3 plus 4R2, so it will be 0, minus 4 plus 4 is 0, minus 5 plus 0 is minus 5 only. Now we have to create another pivot here, so we can divide it by minus 5. So we'll be having 1 0 3 0 1 0 0 0, minus 5 by minus 5 is 1, right? Now what you can do, because we have to create 0 here as well, so we can have, if we take away R3 from it, then we will be having echelon form, right? Now what you have to do when you are using Gauss-Jordan method, you have to simply multiply these with x1 x2, and you have to equate by this column. Okay, so if we take third row, that means 0x1 plus 0x2 equals 1. Are we able to find out values of x1 and x2 from here? No, because we can't equate this, because 0 is equal to 1. What does it mean? So that means yes, hence proved that this system is inconsistent, right? Now first part is over. We have proved that the system is inconsistent. Now we have to find out the least square solution, that means the value of x, because from here we are unable to find out x1 and x2, but still we have to find out at least square solution, that means approximate value for this inconsistent system. How we will find out? Let's see. In it, you can use this least square problem method by the normal equation, where yes, you have this system, but in it you multiply it with the transpose, right? We have studied it in the beginning. So your value of A is what? 2, 0, 1, 0, 1, 2, right? Now you have to find out all these values. A is here, X we need to find out. We need to find out A transpose, and B is what we have. So A transpose is what we do in transpose. We change the rows into columns. So 2, 0, then 0, 1, and then 1, 2. Right? So this is your A transpose. Now substitute here in this equation. A transpose multiply A multiply X, you can simply write it X in the beginning, is equals to, and it is a vector, so you can put vector sign. Then A transpose is 2, 0, 0, 1, 1, 2, and here B. What is the value of B? 1, 0, 3. Right? Okay, solve it. This is what? The order is 2 by 3. 2 rows, 3 columns. This is 3 by 2. 3 rows and 2 columns. Here you have 2 rows and 3 columns again. And here you have 3 rows, 1 column. So the resultant matrix will be having order of 2 by 2. And this matrix will be order of 2 by 1. Now, for 2 by 2 order, first row, first column. So 2 2s are 4 plus 0 plus 1, that is 5. Then first row, second column. 2 zeros are 0, 0 times 1 is 0, 1 times 2 is 2. Then second row, first column, 0 times 2 is 0, 1 times 0 is 0, 2 times 1 is 2. Then second row, second column, 0 times 0 is 0, 1 times 1 is 1, and 2 times 2 is 4. That means 4 and 1, 5. Right? So you've got 5, 2, 2, 5 as elements. Here you have X. Correct? And then on the right side, what you have got is 2 by 1 matrix. Correct? So first row, first column, 2 times 1 is 2, 0 times 0 is 0, 1 times 3 is 3, 2 and 3, 5. Then second row, first column, 0 times 1 is 0, 1 times 0 is 0, 2 times 3 is 6. Okay? So now you can substitute the value, whatever your X values are. So you have in the beginning assumed that X1, X2 are the values, and you can simply find out. Now, when we do we can multiply it. This is 2 by 2 matrix. This is 2 by 1, and this is also 2 by 1, right? So resultant will be 2 by 1. So that means 5x1 plus 2x2 is equal to 5. And then here 2x1 plus 5x2 equals 6. You can solve it for x1 and x2. Okay, so I'm doing elimination. I'm multiplying it by 2 and this by 5. So this will become 5 to the 10 x1 plus 2 to the 4 x2, 5 to the 10. And this will become 5 to the 10 x1 plus 5 5 to 25 x2, 6 5 to 30. You can subtract 25 minus 4, 21 x2, and this is minus 20. So x2 is 20 by 21. Now from here, if you substitute the value of x2, what you will get? 5x1 plus 40 by 21 equals 5. You can divide by 5. So x1 is plus 5 is a 40, 5 is a 5. x1 is equals to 1 minus 8 by 21. So 21 minus 8, 11 minus 3, 13 by 21, right? So this X matrix, which is the order 2 by 1, here x1 value is what? Here 13 by 21, and your x2 is 20 by 21. right? So you have solved the second part, that means to solve the inconsistent system for the values of x. Initially when we were solving it without using the transpose, we were not having any values of x1 and x2, but now we can have it because we have introduced this transpose factor here, right? So this is how we can solve least square problems by the normal equation. Now the third part is you have to determine the least square error as well, because this is the approximate value, correct? We couldn't find out the value, the solution initially. So this is the error. I mean, this will be having an error and we have to find out that error. So how we will calculate it? Here you will be having a system. So for that system you have ax is equals to b is the initial set, right? So if you take the value of ax and take this b onto the left hand side and take the magnitude of it, this will be the least value, okay? So firstly find out this value ax minus b. So a is what? 201012. X is what? 13 by 21 and 20 by 21. We just found out this value. And then what is our b? It is 103. So if you substitute all these values here, ax minus b, and find out the value of, let me introduce this. So ax, a into x is what? A into x is, this is 3 by 2 and this is 2 by 1. So it will result into 3 by 1 matrix. So find it out. 3 by 1, right? 3 rows, 1 column. So first row, first column. So 13 to the 26 by 21. Second row, first column. It will be 20 by 21. And third row, first column. So 13, 1's a 13 and 20, 2's a 40. 40 and 13, 53 by 21, right? This is 53 by 21. So this is your AX. I'm substituting the value here. 26 by 21, 20 by 21 and 53 by 21. Right. Minus B. B is what? 103. So find this out. 26 by 21 minus 1. If you take the LCM, it will be 26 minus 21 by 21. That is 5 by 21. Right. Then you will be having 20 by 21. And then 53 by 21 minus 3. So 53 minus 3, 3 1 is 3, 3 2 is 6. Right? So minus 10 by 21. Correct? But we have to find out the error, that is the magnitude of this matrix. Matrix are vectors, right? If we have to find out the values, the magnitude of vectors, how we will do it? By, let's say if you have AX, by cz and you have to find out the magnitude, so you will do a square plus b square plus c square. So similarly what you will do here, 5 by square root of 5 by 21 square, 3 by 21 square and minus 10 by 21 square. So this will give you 5 5 is 25 by 441, 420 square is 400 by 441 and then 100 by 441, right? So 525 by 441, 441 can come out as 21 only, square root. Now for 525 you can simply solve it, right? 5 is a 5, 5 is a 25, 5 is a 10, 5 is a 5, and then this is this cannot be broken down into pairs, so 5 root 21, right? So this is your answer, or you can solve it into more simpler form by using, by solving the square root of root 21, square root of 21. So this is how you can find out whether a particular system is consistent or inconsistent And then if it is inconsistent, then you can use the least square solution, and you can find out the least square solution by using normal equations. And then if you have found this out, then you can use this same value to find out the least square error as well. That means the magnitude. I'm hoping that this is clear to you. And if so, then don't forget to like, share, and subscribe our channel. Till my next video, take care of yourself. Bye bye.